page 2 of the probability addendum. Number 3, a team of 7 is randomly chosen from a squad of 12, including the club captain and the vice captain. Determine the probability that both the captain and vice captain are chosen. Okay, so let's see. In the number of ways you can choose 7 out of 12 is 12 chooses 7, right? So that would be the denominator. And the numerator would be all the ways you can have 7 chosen from the 12, where both the captain and the vice captain are chosen. So, like, let's say that you have 12 people, and one of them is captain, and one of them is vice captain, and the other ones are just random people. 3, 4, 5, 6, blah, 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 all the way to 12. And we have 7 spots where order doesn't matter. So I'm going to write down captain and vice captain in the first 2 positions, although the order doesn't matter. And then the other positions are going to be filled by players 3 through 12, of which there's 10 players, right? So basically the number of ways these 10 players can fill these remaining spots, and how many spots are there remaining? There's 5. That's basically 10 chooses 5, right? So basically the numerator here would be 10 chooses 5. The denominator would be 12 chooses 7. So let's see. Do that on the calculator. 10 chooses 5 gives me 252. And 12 chooses 7. 12 chooses 7 gives me 792. Okay, let's see if that reduces a little bit. 252 divided by 792, and then we'll change that to a fraction. 7 over 22. Five boys sit at random on 5 seats in a row. Determine the probability that 2 friends, Keong and James, sit at the ends of the row and together. So 5 boys sit at random 5 seats in a row. Okay, so in this case, order does matter, right? And basically we have 5 boys and we're choosing them to sit in 5 seats. So what is the probability that, okay, so first of all, how many different ways are there for 5 boys to sit in 5 seats? That would be 5 factorial, okay, because in the first seat you could have 5 sit down. In the second seat you'd have 1 less because one person's already sat down, so it would be 5 times 4 times 3 times 2 times 1 would be the denominator. And the numerator would be, okay, so we have 5 seats, and the first seat has Keong and James in the last seat, and then basically there's 3 remaining kids, and so the ways we could fill those 3 remaining seats would be 3 times 2 times 1, which is 6. And then there's also the opposite case where you have James and Keong sitting in the opposite chairs, and then that would be 3 times 2 times 1. So that would be 6 times 2, right? Because 3 times 2 times 1 is 6, and we have 2 ways of doing that. So that would be 12 in the numerator. So, and 5 factorial is 120. So we have 112 divided by 120, it's just equal to 1/10. Okay, let's check to see if that answer is correct. Yes, it is. Okay, let's do B. What's the probability that they sit together? Okay, so this time the denominator is still 5 factorial because there's 5 different ways for 5 boys to sit in 5 seats. Or there's 5 factorial ways of 5 boys to sit in 5 seats. And how many different configurations have Keong and James sitting next to each other? That would be Keong and James sitting here, and then 3 empty spots. James and Keong sitting here, and 3 empty spots. 1 empty spot, James and Keong sitting like that. Keong and James sitting like that. James and Keong sitting like that. Keong and James sitting like that. James and Keong sitting like that. Keong and James sitting like that. So, in the end, we have all these different ways. And there's 1, 2, 3, 4, 5, 6, 7, 8 ways for James and Keong to sit next to each other. And then the 3 remaining spots could be filled 6 different ways each. So that would be 8 times 6 in the numerator. So that would be 48 in the numerator and 120 in the denominator. And let's check to see if that is correct. Let's see. If we reduce it, we could divide both the numerator and the denominator by 12, and we would get 4/10. Also could be reduced to 2/5, right? So yes, it's correct. Number 7. 6 people, including friends A, B, C, are randomly seated on a row of 6 chairs. Determine the likelihood that A, B, C are seated together. So, how many different ways are there to arrange 6 people in 6 chairs? 6 factorial. So the denominator is 6 factorial, kind of like before. And the top, basically we got A, B, C sitting together. And then we have 3 empty chairs. Okay. And how many different ways are there to arrange A, B, C? There's 3 times 2 times 1 ways, right? So how many different ways are there to have A, B, C sitting together? There's basically 4 different configurations. But among these 4 different configurations, A, B, C could be arranged in 3 times 2 times 1 different ways, 6 different ways, right? And the remaining 3 chairs could also be arranged in 3 times 2 times 1 different ways, 6 different ways. So basically we got 4 times 36, which is 144, divided by 6 factorial. So that would be 144 divided by, 144 divided by 6 factorial. Math. 0.2. Let's check to see if that is correct. Yeah, it is. 1/5. All right. And that's it. That was a quick page, wasn't it?